And the derivative of y equals 4x plus 3 to the 3 halves divided by the fourth root of x squared plus 1. So y here is the quotient of two functions. We have the 4x plus 3 to the 3 halves power divided by the fourth root of x squared plus 1. And therefore we'll make use of the quotient rule for the derivative. But before we do that, let's rewrite the denominator as a fractional exponent. The numerator I'll just leave the way it is, so 4x plus 3 to the 3 halves power. And in the denominator we have the x squared plus 1. And it's to the first power and fourth root, so 1/4 power overall. The derivative, y prime, which can also be called dy dx, will be the quotient rule overall. Derivative of the numerator, it's a power function, so we'll bring the power down 3 halves. We have the inside left alone. We're going to subtract 1 from the power, so 3 halves minus 2 halves, and then multiply by the derivative of the inside of the power function to complete the chain rule. That's all the derivative of the numerator, multiplied with the denominator left alone, minus the numerator left alone, so 4x plus 3 to the 3 halves, times the derivative of the denominator, which is a power function. So we're going to bring its power down. That'll be a 1/4. We'll leave the inside alone for that one. Subtract 1 from its power. I will call that 4/4. And then multiply by the derivative of the inside to complete the chain rule. All this is divided by the denominator squared. So the derivative y prime, or dy dx, will now equal to, in my next step I'm going to collect together the constants. So I have a 3 halves and I have a 4. I'm going to multiply those. 4 times 3 halves is 12 halves, or a 6. I then have the 4x plus 3, which will now be to the 3 minus 2, 1 half power. And I have the x squared plus 1, that is to the 1/4 power, minus, now for the second term, I'm going to also multiply the constants. I have a 1/4 and a 2. Multiply those, that'll give us 2/4. Well, 2/4 will reduce to a 1/2. And I also have an x. There's the x right there. Everything's multiplied, so I can move that to the front. So x. And I have a 4x plus 3 to the 3 halves power. And I have an x squared plus 1 to the 1 minus 4, negative 3/4 power. All this is divided by x squared plus 1 to the 1/4, and then raised to the 2. Now when you raise and raise again, you multiply those exponents, so that's going to go to a 2 times 1/4, or 2/4. So what I have here is 6 times a 4x plus 3 to the 1/2 power, and x squared plus 1 to the 1/4 power, a minus, and then with the second term I'm going to rewrite it where I move this negative exponent into the denominator, which is going to put it with the 2 that's down in the denominator from the 1/2 in the front there. And the numerator will be made up of these three things, so 1 times an x times the 4x plus 3 to the 3 halves. Those will all stay in the numerator. So I have minus an x times a 4x plus 3 to the 3 halves power, divided by a 2 times an x squared plus 1 to the 3/4 power. All this is divided by x squared plus 1 to the 2/4, which we can write as reduced to 1/2 power. Now we have a fraction in the numerator right here. We're going to need to combine that with this term, so we're going to need to produce a common denominator between those two. That's going to be our next step. So y prime, or dy dx, is going to equal, we have the 6 times the 4x plus 3 to the 1/2 power. We have the x squared plus 1 to the 1/4 power. And the common denominator is going to be the denominator in the fraction, since we don't have a denominator for this other term. So that is the common denominator. We're going to multiply this by 2 times x squared plus 1 to the 3/4 power over itself. So that we produce a common denominator between this and the other fraction that is in the numerator. We will then be able to combine those terms together. And all of this is still over the x squared plus 1 to the 1/2. Now this first term, everything in the numerator is being multiplied, so this is all being multiplied here. Now, we can move things around because multiplication can be done in any order, and that 6 and that 2 can multiply each other to become a 12. I will start with that. So we have a 12. We have the 4x plus 3 to the 1/2. I also have this and this, which can multiply with each other. And when we multiply like base, we add the exponents. X squared plus 1 to the 1/4 plus 3/4. 1/4 plus 3/4 is 4/4, or just 1. So all of that will become x squared plus 1 to the 1st power. And then we have minus the other numerator, which is x times 4x plus 3 to the 3/2 power. All of this is over that common denominator, which is 2 times x squared plus 1 to the 3/4 power, and then the entire thing is divided by the overall denominator, which is x squared plus 1 to the 1/2 power. Now, what we're going to do with this in the next step is we're going to reciprocate that denominator. I'm going to put it over 1, so it's now a fraction, so I can reciprocate and multiply it with the numerator. Now that I have a single fraction in the numerator, we can reciprocate the denominator fraction and multiply it. So y prime, or dy dx, will now be, we have a 12, a 4x plus 3 to the 1/2, and x squared plus 1, minus x times 4x plus 3 to the 3/2, all of that divided by 2 times x squared plus 1 to the 3/4 power. And we're going to reciprocate, in which case I will have 1 over x squared plus 1 to the 1/2 power. Reciprocate and multiply. Now the thing is, I'm going to multiply these fractions. I multiply the numerators, I multiply the denominators. When I multiply the denominators, I have a like base here, and I'm going to be adding their exponents. Well, right now I have a 3/4 and a 1/2, so I'm going to want to rewrite this 1/2 instead of writing it as 1/2. Let's multiply by 2/2 and call it 2/4, because then we can add those exponents. Now the numerator is just going to be 1 times everything else, and so I will just get that same numerator, 12 times 4x plus 3 to the 1/2 times x squared plus 1 minus x times 4x plus 3 to the 3/2 over, I have a 2, and then I'm going to have an x squared plus 1, except now you add these exponents, so it'll be 3 plus 2, or a 5/4 power. The last thing we're going to be able to do is factor the numerator a little bit, and that should simplify our result. So y prime, or dy dx, will be, in the numerator we have 4x plus 3 in both terms. We can factor it to the lower of the two powers. We have a 1/2 and a 3/2. We can factor out a 1/2 power. So 4x plus 3 to the 1/2 power being factored out of the numerator. Now when you factor out your dividing, and dividing means a subtraction of exponents, and I'm factoring out a 1/2 power. So I'm going to be subtracting a 1/2 from this. That will give us 1/2 minus 1/2, which is 0, and anything raised to 0 is 1, so we've completely factored that out. And then I'm going to be subtracting a 1/2 from this, and 3/2 minus 1/2 is 2/2, or a power of 1. And so that'll just be a power of 1. And there's what we should have left after factoring out. So we will have a 12 times x squared plus 1 minus an x times a 4x plus 3 to what will be now a 3/2 minus 1/2 because of the factoring, or 1 power. And all of this is over that denominator. Of 2 times x squared plus 1 to the 5/4 power. The last thing to do is to simplify in the square brackets. And another thing that we can do, this 4x plus 3 to the 1/2, we can rewrite, because it's first power, second root. We could just write it as square root. It'll most likely be found that way when you see a 1/2 power. But in the square brackets, we'll distribute the 12 in here. So that'll be 12 times x squared, 12 x squared. And then 12 times this 1, which will give us a plus 12. We will have a negative x distributed into here, a negative 4x squared, and a negative 3x. And all of that divided by 2 times x squared plus 1 to the 5/4. The only thing left to do is combine the like terms together in the square brackets, if there are any like terms. And it looks like there is. So we're going to have the square root of 4x plus 3 times, we have a 12x squared and we have a minus 4x squared, so that'll be an 8x squared. We also have a minus 3x, and we have a plus 12. Those didn't have anything else to combine with, so we'll just write them in there. And this entire thing is over that denominator of 2 times x squared plus 1 raised to the 5/4 power. And there's our derivative, simplified, y prime or dy dx. Square root of 4x plus 3 times 8x squared minus 3x plus 12 divided by 2 times x squared plus 1 raised to the 5/4 power.